When we issue a ping on PC1 from PC1 to PC2, there, we have seen that PC1 will create an IP packet. Let me change the color here. An IP packet with this destination address, which obviously is the destination address of PC2, and the source address is PC1's own source, own address. What PC1 will do is it will realize that this destination address here, that is not on my network because I am on a 192.168.10 network decided by the /24 here. So what PC1 will do is it will send the packet over to the router. And I'll do that now here. And there it went over to the router. But how did the PC1, how did it know that it had to send that IP packet with that destination address over to the router? How did it know that it was the .1 address here, the 192.168.10.1 address that it had to send it to? That is what we're going to look at here. I'll rearrange the things here a little bit and bring up workstation so we can see how to configure PC1. So we're going to look at the settings for PC1, and that is what we have here. So I'm going to go into the networking settings and see what they are and make them fit our needs here. I'll actually start by disabling the networking interface. So I've done that there. I'll click again and I will choose edit connections. We actually only have one connection in on PC1, and that is what we're going to look at here. Wired connection to IPv4 settings. Let's check them out, and here we have them. The IP address for PC1 is has to be this one over here, 192.168.10.2. We can already see that that is not good. It is not set here. And we have something very important over here also, the gateway. Nothing has been set there at all. So that is what we're going to do now. Let's first get the right IP address here. It's 192.168.10.2. So that is okay now. It's indicated by green here. And here comes the new thing. We have to put in here a gateway. That is the address, the IP address of our router. So that would be 192.168.10.1. That is what we're going to enter here. This will instruct PC1 where to send packages that is not for my own network. So 192.168.10.1, and it lights up in green. We are happy about that. Let's save that and close our network connections editor here and monitor. So after having set these parameters, IP address and gateway, we will restart our networking connections here, our networking process on our Linux box. We can now take a look at the routing table on our Linux box. Yes, our Linux box also has a routing table as has the router itself. So I'll run the route-n command here and see what I have in the routing table. And so in here we can see our settings that we have just made, or some of them at least. Look at this here. We have gateway. That is 192.168.10. That is the address that we have just put in here for our router here. And we can see if a package is for this route here, I'll mark the entire route now. This route here, that packet has to go out on ENS33, and that is the PC1 interface down here, ENS33. So when PC1 wants to send out a ping, in this case for this destination address here down in our IP packet, it will make a lookup in its routing table and find the best match that it can. If we start from the bottom, do we have a match here with the 10 network? No, not really. Does this here match, whatever it is? No, not really. Does this here match 000? Yeah, because 0.0.0.0 means any IP address. So this route here actually matches any IP address, but that is only checked after all other options have been checked. So in this case here, the 000 route is the best match, and that is exactly where we have our router sitting on the 192.168.10 IP address. So this packet here will be sent to the router out on ENS33. Even though the IP address here is 192.168.10, that doesn't alter the IP packet here. The source IP and the destination IP in the original IP packet, they stay the same. The only thing that is taken from the routing table is that it has to go out on ENS33. There is a bit more to this story, and that concerns MAC addresses, and that is what we will be looking at shortly. One smart way to figure out what your default gateway is in on your Ubuntu or Debian Ubuntu box is to run the route command without the -n option. -n means name resolution is disabled. So if we run with name resolution switched on without the -n, we get this here. So let's take a look at it. We can actually see here that it's the same routing table, obviously, but now with name resolution. So default gateway is sitting here. Default gateway, it says that in clear text, corresponds to this route that we have up here. So default 000, what is the gateway? It is 192.168.10. That is where it should, packages that are not destined for the PC1 network, the network that PC1 is on, should be sent to this IP address here. The gateway for PC1 is the .1 up here, and the same counts for PC2. The gateway for PC2 is .1, but obviously it is the 192.168.11.1 address that is PC2's gateway. So for PC1, this is PC1's gateway over here, and indicated up here by the default entry here, default gateway, shown in two different ways, by the route command, the route without -n, and the route with -n. As we have now configured PC1, we will do the same for PC2. PC2 is not powered on, so I will do that. And PC2 is powered on. I will log into it. And I'll go into network settings, edit connections. The IP address is correct. The subnet mask is correct, 24. That is taken from over here, -24 there. And the gateway is actually also already set correctly. It's 192.168.11 network.1. If If these settings are not correct according to our network diagram, then just correct them and click save. But everything's okay here and fine. So I'll just say I can save it again, cancel, and restart the networking.